Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's SecurityBoulevard.com program, brought to you by TechStrong and GitGuardian. My name is Cody J. Brown. I'm the host of TechStrong Learning, and we have an exciting program ahead. First, I do need to cover just a couple of housekeeping notes. Today's session is being recorded, so if you miss any of our discussion, or maybe you'd like to watch again later or share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, and we really hope that you do, we want you to send those in to us using the Q&A tab. You can find this tab along with the chat tab on the right side of the screen. And so before we close out of today's program, we are also giving away 4 $25 Amazon gift cards, so be sure to stick around for the duration of today's program. So on to the topic of our webinar today, Secrets Management and DevSecOps, an Enterprise Maturity Model. And I'm joined by Mackenzie Jackson, developer and security advocate at GitGuardian. Mackenzie, thanks so much for joining me today. I'm going to let you take it away from here.
Awesome. Well, thank you for that introduction. It's great to be able to be here with everyone today. As said, all around the world, these great things about these online events is that we can be tuning in from anywhere. I do want to try and make this an interactive kind of session, or as interactive as possible. So you'll notice that there are some ways to communicate with me via questions, via chat. So why don't we start by letting me know in the chat section whereabouts everyone's tuning in from. I'm currently coming to you from a town called Utrecht in the Netherlands, about 30 minutes out of Amsterdam. But let me know where you're tuning in from. I'd love to hear from you. But while we're doing that, I'm going to get my slides up on the screen so we can get started into Brazil, Chicago, Florida, Austin, Texas, LA. Some great locations. I love how these things can be so international. So today's program is going to be on building a maturity model in DevSecOps for secrets management. And we're going to uncover a lot of what all of that is about as we go through the program. But just to give you an idea, what we're going to be looking at. So first, I'm going to be looking at some of the problems that we have with secrets and exactly what secrets are. Because if you're not familiar with that term, don't worry, we'll cover that quickly. And then we're going to look at some high-profile incidents. I always find it's very relevant when you can actually see what results of security issues, what happens in the real world. And we're also, whilst we're doing this, we're going to look at some research that has been done about secrets, specifically about leaked secrets. And then we're going to dive into the maturity model that GitGuardian's put together on what it looks like when you have a successful secrets management program. It encompasses a lot of different elements that we will talk about, and then following on from this, we'll dive into some of those specific elements and what that actually looks like holistically in an organization to have high quality and a mature program in managing secrets. And then we're going to have a Q&A section down there. Cool. So let's start off with the problem of hard-coded secrets. So when we're referring to secrets in software development, what we're referring to are kind of digital authentication credentials. And these can really be defined as anything that gives access or allows you to view or access data, infrastructure, systems. So really anything that authenticates you. A big difference between what you might call credentials and just secrets in general is that these don't have to be password, username and password combinations. These are things like API keys, security certificates. They could be encryption keys, really anything that grants you access to system or services. And they're not just used by humans, they're also used by machine to machine kind of communication and authentication. So these secrets are made to be used programmatically. So what I mean by programmatically is that we use these in our systems, in our tools, which means that there's a really high candidacy and high likelihood that these end up in places that they're not meant to, because we lose control over these things. For instance, if they end up in our source code, these are going to be sprawled in multiple different places that we'll talk about throughout the ads. But that's what I'm meaning when I'm talking about secrets. So when I'm talking about hard-coded secrets, I'm referring to these being inside our source control, these being inside our source code, and really ending up in lots of different places that we don't intend them to be. So I want to talk about some research now that we have. I have up here a site that probably you're all familiar with, GitHub. There's 83 million plus developers that are currently using GitHub, according to them. And this is the largest code sharing platform on the internet, as you're probably aware. This is basically where we share open source software. This also is used by really like a portfolio for a lot of developers to showcase their work. So there's huge amounts of open source libraries and source code that's on github.com, particularly publicly. So one thing that GitGuardian does each year is we actually monitor various different public spaces for the presence of secrets. One of the places that we monitor is on github.com. We actually monitor every single commit that's made. So if you've pushed code or if you've uploaded code to GitHub, GitGuardian has scanned that to try and find it for secrets. So you might ask, how many secrets do we really find in GitHub every year? So last year, throughout the entire 2021, we released this report every March. But so last year, throughout 2021, we found 6 million secrets, 6 million credentials, 6 million API keys, security certificates, database credentials, encryption keys, things that can grant access to sensitive systems. 6 million of these we found throughout the year of 2021. To give you an idea of the scale, we scanned over 1 billion commits during this time. So what we find is an average of 3 commits out of every 1,000 that is made on the platform, contains some kind of secret. And these aren't just kind of things that may appear to be secrets, but are actually kind of unique identifiers. We validate these secrets with third-party providers often. We do a lot of post-analysis on them to ensure they're not test credentials where we can't validate them. So we have a high confidence that the number that we present here is fairly accurate. So that's huge. And it's not just kind of personal things. It's very common that accidentally organizations' code gets published, or parts of it gets published publicly. We'll talk about that later. So this can be sensitive information belonging to an organization that could grant attackers access to different things. So really big problem when it comes to secrets inside our source control, or what we call hard-coded secrets. Another site that you might be familiar with is Docker Hub. So Docker Hub is the largest kind of registry of Docker images. If you're not familiar with what a Docker image is, it's basically a collection of different tools, a snapshot in time of everything that you need for your program to run. So it's a very lightweight version of a virtual machine, great technology. But often this is how we run technology nowadays, right? We run Docker images. So another place that we looked for sensitive information was in public Docker images. How many of these public Docker images actually contain secrets? So Docker may seem like a little bit of a black box mystery technology sometimes, but what you always have to remember with these things is that it's just code, right? So if you give code and you create a Docker image out of code, that code is going to be in a Docker image. It may change, may be obfuscated, but it's still code. If there's a hard-coded secret in there, it's going to be in a Docker image. So we found that around about 5%, 4.62%, the publishers of the report are very pedantic, but 4.62% of Docker images from our research contain at least one plain text credential. So we scanned 10,000 images. We found roughly 4,000 different secrets, and about just over 1,000 of those were unique secrets. So there's over 8 million images on Docker Hub. So when we extrapolate this out, there's a huge number of secrets that are just sitting there out in the open. And we'll talk about breaches that have happened because of this exact mismanagement of our secrets. The final place I'll talk about, and then we're going to move on from research and into some different areas, is secrets in internal repositories. So At GitGuardian, we have a product that can help kind of identify where secrets are in your internal systems. So using that information, we published what we find in our typical users. So the average company size is around about 400 developers. And what we see in the company of 400 developers is there's around about 4 application security engineers in this. That company, we typically find about 1,000 different secrets inside their internal version control systems, inside their internal Git repositories, or inside whatever other source control that they're using. So that's a huge number of secrets, and these are kind of very sensitive because they belong to the organization. They could be data, they could give access to database, they could get access to payment systems, they could give access to encrypted files, all these types of things. And this is inside an internal repository. One of the shocking kind of numbers that we see from that is that what we find is that every unique secret has about 13 different occurrences. So in this case, we'd have 13,000 secrets total, 1,000 of which are unique. But if we look at that 13,000 total secrets, each one of those has to be investigated, has to be kind of communicated with the developer to find out what they are. They may need to be replaced. You need to publish new keys. You then need to republish that service. You need to do all this without disruption. And that's 13,000 secrets, 13,000 times you need to do that. If you have 4 AppSec engineers, that's 3,400 times each AppSec engineer has to do this, right? It's an unmanageable problem, which is why it's so important that we build strong maturity models to kind of prevent us from getting into this situation. Because once we're here, once we're kind of at this daunting task of we've decided to look to see if there's a problem with secrets management, and we've found all these secrets scattered throughout our internal systems, well, now the problem is kind of so daunting, it's just easier to ignore in reality. And a lot of people do. So, this is where we're at with exposed secrets. They're being exposed in public repositories. They're being exposed in public Docker images, and also private Docker images, ones that might be shared to certain clients. And they're being sprawled in our internal source control systems. And all of this isn't because of one thing. It's all because of a collection of different things that we'll talk about later on. So now I want to talk about some high-profile incidents that have actually involved some secrets. So I find, it's all very well talking about research. I can throw really scary numbers at you all day, but what actually happens in the wild? Do adversaries find these secrets? Are they actually sensitive? How do they use them? So let's talk about that. Let's find some high-profile cases where adversaries have actually used these secrets to cause harm. So the first one is CodeCope. This is going to relate specifically to Docker images, but also to private Git repositories that we'll talk about in a minute. So first of all, if you're not familiar with CodeCope, it's a great tool. It sits in your CI/CD environment. It sits in kind of your testing area. And it does something simple. It's a code coverage tool. And basically, it tests how much of your application is being tested. So it does a very specific thing. You put it into your systems, and whilst you're automatically testing your application, CodeCope's going to see how much of that application is being tested, if any features are not being tested. So this isn't something that you would think of as being hugely critical, right? It's important. It's a really cool tool, but it does something very, very, very specific, and it sits in your CI/CD pipelines. So there was actually a big supply chain attack that happened last year, January of last year, where adversaries ended up inside internal systems of CodeCope customers. So what actually happened? So the official Docker image that CodeCope was using had a hard-coded credential in it. So this image was using a file. To access that file, it needed a secret. It needed authentication. That secret wasn't handled correctly, and someone hard-coded that into their source code. That source code ended up in the Docker image. Anyone could have downloaded that Docker image. It was on Docker Hub. It was the official image that people were using. So everyone was using that same image. Anyone could have looked in this and found that hard-coded secret had they known what to do it. Unfortunately, an adversary did. And then they got access to some of the source code of Docker. Now, specifically, they got access to a bash uploader script that a lot of customers were using to automate some processes. It's not really important to go into details about it, but they were able to edit that bash uploader script. They were able to inject a malicious line of code, just one line of code. The script had about 2,000 lines of code in there. So, there's one kind of line that's easily hidden. And basically what that line of code did was it said, whenever an application is being tested in that CI/CD environment, that CodeCope sits within, I want you to take all the environment variables. So I want you to take all of the secrets that application needs to run. I want access to the database. I want access to your tools. I want access, and I want you to send all of those secrets to me, the attacker. So every time, oh, the sound has gone. Is my sound fine? Okay, I'll keep going, assuming that it's okay.
Sound is fine.
Okay, perfect. So this kind of continued. So once the attacker had all these secrets, every time a CodeCope user ran that application, all the secrets that were being used were being sent to the attacker. So CodeCope at the time had customers like HashiCorp, Twilio, Monday.com, Rapid7, all of these different customers. Every time they ran CodeCope, and it was run automatically in their CI/CD environments, multiple times, probably a day, all those secrets were then sent to the attacker. That what the attacker was really after was access to private code repositories. So they moved from CodeCope into the private code repositories of these other companies. So HashiCorp, Twilio, Monday.com all had to announce breaches that they had because the adversaries had made it into their internal systems because of this. And what was more significant is that they all had additional secrets in their private source code. So this covers a whole lot of areas. We had secrets publicly in Docker images, and then we had additional secrets in private companies of private source code repositories of different companies. And the attacker was able to access all of these because of this one hard-coded credential. So here's a very significant kind of real-life example. What happens when you hard-code credentials and they end up in a public Docker image? So moving along, we've seen a huge trend of private source code being involuntarily open sourced. So I mean, involuntarily open sourced by basically being leaked to the public. Lapsus this year did this with a whole bunch of companies: Microsoft, Nvidia, Samsung, and last year Twitch's source code was also leaked. So I'm going to focus just on Twitch for the moment. So what happened here was that there was a misconfiguration with how their code repository was set up. And so briefly, it allowed remote access. It wasn't set up that way, and it didn't remain that way. It was just a short period of time where a configuration error was made. An adversary scanning the system was able to find that was remotely accessible, accessed it, downloaded all of Twitch's source code, every single repository that they had for every single product that they had, and then published it online. So what was actually inside that source code? So there was some media coverage about how streamers' income was leaked, but actually it was much worse than that, because we scanned that for secrets and we found well over 6,000 secrets in there. And just to kind of emphasize this isn't shaming Twitch. This is basically what we would expect with any organization that's Twitch's size, based on kind of what we typically find. So 6,000 different secrets that the attacker, could then use. Now, the attacker in this case, or malicious actor in this case, was less malicious than they could have been, because they immediately published this online as basically, a screw you to Twitch. Had they wanted, or had they had more malicious intent, they could have kept this quiet, scanned this for secrets, and use these to access different areas, maybe shut down services, access more sensitive data. The fact that they published it online meant that Twitch knew about it. So that's really important. But what did we find? Well, we found over 194 AWS credentials that were inside Twitch's source code repositories. We found 69 Twilio keys. We found all these different secrets, even 4 Stripe credentials. So access to payment systems were inside this source code that was now all public. Now, as I said, because Twitch knew about this, they were able to rotate basically all their credentials quite quickly. It would have been one heck of a job. But the point here is that we can't maintain that our private source code is going to stay private, right? If we don't have good secrets management, then we could end up in this situation where our source code, a small configuration error, leads to all of our source code being leaked. And inside that, there's thousands of secrets that adversaries can then use. The last one, before we start getting into some more meat of actually what it means to secure our secrets, is we're going to talk about Uber. So the Uber breach just happened. Uber has actually had a number of different breaches, all of which involved secrets. But I'm just going to talk about the one that happened in September of this year. So this one was well in the news, and basically it was almost a worst case scenario of what can happen if you mismanage secrets even slightly. So there were the first access was actually, there was some credentials to a contractor hired by Uber that were published on the dark web. So obviously a contractor had their credentials maybe accessed through phishing campaign, maybe it was through a different breach, but this person's credentials were bought on the dark web. We see this happening a lot. You can buy access to different companies, employees on the dark web. The attack was initially stopped by multi-factor authentication, but through basically spamming and some social engineering, the contractor actually accepted the request for multi-factor authentication, and the attacker was then granted access to the VPN, which granted access to Uber's internal network. Now, in a perfect scenario, having access to an internal network is bad, but not critical, right? Because you can't destroy much from here. Maybe you can access some sensitive information if it's not segmented well, but you shouldn't really be able to kind of disrupt an entire company. Unless, of course, you have secrets in your internal network. So once the attacker had VPN access, they started scanning through Uber's internal network, basically scanning documents to see if they could find any secrets. And they did find them inside a PowerShell script. And they found the most critical secret that you could ever imagine. Inside a PowerShell was a plain text hard-coded credential to a PAM system, a privileged access management system. You can think of this, a PAM system, as basically your password manager and your secrets manager rolled into one, but for your entire organization. So they had admin access into the PAM system, which basically meant they had access to every single secret in the organization that was stored on this system. And it looked like there was a huge amount of secrets that were stored on here. Because once they had access to the PAM system, it's called psychotic, they then were able to move laterally into their AWS instance, into their Google Drive, into their Slack channels, into their SentinelOne account, into their email, their Google Suite Manager, and they had admin access to all of these different things. So again, the attacker here didn't have huge malicious intent because they didn't disrupt Uber services. They basically were just kind of after publicity. They started spamming Uber in their Slack channels, kind of laughing at them. So that actually could have been much more malicious had they wanted to, because they had access to so much. And they even had access to kind of SentinelOne, which you can think of as the alarm system to try and detect them. So because they had access to SentinelOne, they could have remained undetected, and they could have planned a really malicious, really bad attack on Uber from this. They didn't, luckily. But again, here's another case of, there's a hard-coded credential in a PowerShell script due to some poor password management, and all of a sudden an attacker has access to everything. Now, this is the worst case scenario, but there are 3 different examples where secrets have been exposed in different areas, which basically shows a huge need to be able to protect these things a whole lot better than what we're clearly currently doing. So how does this all happen? And we can talk about this as basically unsecure software development practices. And secrets are really unique when they're in our source code. So, and there's a specific reason for this. And if you're not familiar with kind of how our version control systems have worked, there's an illustration here, but basically what you need to know is that everything you do as a software developer is maintained in your history. So in the case that's happening on the screen, if you hard code a secret, just quickly, you have full intentions to delete it later, you just want to get something happening fast. If you hard code that, delete it quickly later, and then merge that into the master, it will go through a code review. There'll be no secrets there for the reviewer to find, and that will all go ahead. But deep in that history, that secret still exists. It still lives on. And this makes the problem of secrets really, really tricky, particularly in source code. Why? Because when we look at all other vulnerabilities that we can have, so if we're looking at kind of Stack Overflow, or if we're looking at cross-site scripting vulnerabilities or SQL vulnerabilities, or all these kind of injection type or whatever we want to talk about, it all exists in the latest version of the app. It doesn't matter if version 1 was insecure. If version 2 is secure, and that is the version that we're running, that everyone is running, then your application is secure. That's not the case with secrets, because the vulnerability exists in your systems, in your source code, and there's a complete history of that forever. Right? Now, we can delete those secrets, we can remove those secrets from the history, yes, but that can be very, very complicated. And we can rotate those secrets, yes, but we have to be aware that they're there. So this is why it's a fundamental problem when it comes to our source code that's different to other vulnerabilities, because just because we've removed it later on doesn't mean that our application is secure. It may not be in our runtime environment, but it's still in our history. And if an attacker gains access to our internal networks, that threat is still present. And this is basically because security and operations is not moving as fast as development is. Right, we all know the agile kind of methodology. We're introducing DevOps. We're deploying applications 457,000 times a day or whatever it is now, but we're moving really, really quickly. And we can do all this because of automation. We can control everything from code now with GitOps and other areas with our CI/CD and pipelines. We could automate different deployments, processes. It's fantastic, and I'm not discouraging this, but security hasn't kept up. And a lot of what enables us to be able to move so quickly is our heavy reliance on secrets. So for example, we don't need to build credit card processing into our applications anymore. We can just use Stripe. But let's extrapolate this to just about everything that's not core to our application. We don't need to manage our own databases. We don't need to manage our own infrastructure. We don't need to kind of even manage our own search functionality within our application. We can just use Algolia. We don't need to manage our authentication. We can use Okta or Auth0. Every part of our application that isn't critical to our core business or the core process, or the core processes that we're delivering, the core value, we can just put that off to third-party applications or third-party services or open source tools. What that means is that now we have to manage all of these different secrets, and the speed that this has enabled us has outpaced our secrets management for most cases. So these two areas here is really why it's super critical that we build good secrets management programs and processes in our development lifecycle. So there's a lot of ways that secrets get exposed. So they might be committed for testing purposes. What we just talked about, a developer is quickly trying to get something happening. You want to test that they have database access. They want to test that they have Stripe access. They hard code it. Later down the track, they handle it as environment variables or whatever the way that you're securely doing that is. But that secret is still there. And even if it's for test environments, it's still a foothold into the organization. And you can still leapfrog to other areas, because if you get access to test environments, then you might be able to persist an attack long enough or squat in there long enough to try and gain real credentials into the production environment. It happens all the time. We see this a lot when private repositories are made public. This is a big one. And something that attackers really look out for on places like GitHub is that if a repository has been private for a long time and it's made public, perhaps you're open sourcing this tool that you've been using, you're making something public, then that whole history is made public with it, not just the latest version of it, that whole history. So if a year ago, when you felt secure behind the safety of authentication in your source code, now that's all public, and everything you did a year ago was public. And if someone hard-coded a credential a year ago, that is now public. So this is one way where secrets really quickly can expose themselves. We find secrets in lots of places we don't expect. So maybe we didn't hard code that secret, but we did a debug log, and inside that debug log, there's a printout of our environment variables, right? Because we need to be able to see what we're connected to. We accidentally commit that into our version control system, and now that is mixed in with all the code, and that's in the history, that's in backup files, that's in our wikis. So all of these different areas that now we're exposing secrets, even if we're not even aware of it. And that's quite important, because you may think to yourself that you have the best developers and the best security team in the entire world. They would never hard code a secret. They know that that's terrible practice, but they auto-generate a file like a debug log, and the secret's there as well. So it's not even mistakes that we always make. We often see sensitive files inside our repositories, .pem or .env files. Git's one of the superpowers of Git is that it's very quick to use as a developer, but that also means that we can accidentally capture a whole lot of files that aren't meant to be in our version control. And of course, we can accidentally push code to the wrong repositories. If you're a GitHub Enterprise user, one thing you may not know is that your developers have one account for their personal and professional use most of the time. So that means that they're authenticated into two different areas, and just a wrong command can send code public in a place that it's not meant to be. So we can now get into kind of, hopefully I've scared everyone enough that we can actually talk about what it means to have maturity in secrets management. How do we actually achieve this, and how do we do this? So first, we have a poll at the moment. So the first poll that we have up is, I want to know, do you currently use automated secrets detection as part of your management strategy? So do you manually detect secrets at different stages? Is this an automated process, or do you have no secrets detection in your management systems or programs at the moment? Be very curious to see, and if we could get the results of that up on the screen once we get some results in here. So that's great to see. So 36% have automated secrets detection. So that's really encouraging to see. But 50%, the biggest number there, doesn't have any. So that's not encouraging to see. But that is, kind of what we'd expect. And we have some manual detection. So we'll talk about the different areas of this as well. If we could switch back to the slides now. Thank you all for participating in that. We've already talked about this figure here. So I'm going to get straight into the pragmatic approach to secrets management in the software development lifecycle. So this is something that GitGuardian has been working on with various partners and security teams and analysis of different companies that we work with, to try and come up with varying stages of what it looks like when you're starting out in a mature management program and when you're an expert in this field. So the one thing that I always like to stress is that this isn't like something that you can purchase a tool set for, however expensive it may be, and then go from 0 to 4. It doesn't work that way. I work for a security vendor. I would love to tell you that if you purchase our product, that you get to level 4 and you don't even need to worry about it anymore. But that's not the reality with almost any area of security. It requires multiple different steps, multiple different stakeholders. And getting up to that expert level is a journey, but we need to be aware of what that journey actually looks like, and how to get there, right? Because when we get to that point, we said before, there's 13,000 secrets in our internal repositories. This is typically what we find. And now, like, what do we do? Oh my God, this is so daunting. Well, we need to go through the levels, and there's different areas of what we do. Up until level 2, between level 1 and level 2 is where most of the organizations that we work with kind of are, and they're on their journey up to level 4. But up until level 2, you're at extremely high risk of secrets being exposed, either publicly or in your internal systems in different areas. So there's 4 categories that we look at in this topic, which is going to cover everything. But for the purpose of us not being here for 2.5 hours, I'm just going to look at the top 2 categories, which is our developer environments and our source control, our version control system. So you Git repositories or whatever version control system that you're using. So when we get to level 0, there's an alarming amount of companies that are kind of here. We saw in that poll that 50% of the people that answered that poll had no secrets detection. So this is kind of like between level 0 and level 1 is where they might be. So basically here in our developer environments, people are storing files unencrypted, right? So this is when you have your secrets.txt file. Now you may think you're not there, but have a look on your developers' machines and their environments. You may be there unknowingly. And so we're not encrypting our secrets when we're sending them, we're in transiting. We're not having any detection, so we have no idea where they are. And these are, even if they're not intended to be checked into our source control, they're going to be there. I can guarantee it. So this is kind of where we're at. So hopefully we're already past this point, but a lot of companies are still here. Then we get to level 1, kind of like the beginner's area, but we're at least thinking about the problem, right? And there's no shame for where anyone is, because if you're aware that you're at level 1, then that means that you're on your journey to become better because you're at least aware of the problem. So here we're starting to see some changes. So what's happening? So our developer environments, we still have configuration files that contain hard-coded secrets, plain text secrets. You know, we might have a .env file that we're storing on our local machine. We might have different YAML files that we're using, and we may be trying to keep these out of source control, but they're still kind of sprawled through developers' machines. They're going to be backed up into different areas. So our risk of exposure here is still quite strong. And what we have is that we've got no detection on our developer environments here as well. Moving down to our source control, what we see here is that secrets are now starting to be grouped in configuration files and accessed via cloud environments. So they're not directly stored in our source control, but there's still a really high risk of kind of exposure in there. And we're also kind of starting to externally store our secrets in different environments. Maybe we're using AWS or GCP, different cloud providers, to kind of contain some of our secrets. But we don't have kind of overarching policies. We don't have strict rule-based control over where these are. And at this place, we may have some infrastructure to our code kind of templates that are being scanned manually or at different stages. But what we're lacking in the secrets detection stage here is that we're really lacking that automated detection over all of our systems. So here we can best describe it as we're aware of a problem, but we haven't got the correct tools in place to really kind of start to nail this. So we're still at a very high risk of exposure at level 1. So now we're moving into level 2, and this is kind of the first step. You're still at a really high risk of exposure, but this is the first step. We're actually starting to see some maturity in that in some of the areas. So the first thing is that we're not storing secrets in plain text on a developer's machines, right? You're not going to find secrets.txt files inside repositories. Developers don't have access to kind of the plain text config.yaml files that contain all the hard-coded secrets. But instead, we're storing our secrets in a vault. We're sharing these through a secret manager, so it's securely being shared. And we're correctly storing these on our developer machines to make sure that we don't make a mistake and accidentally kind of detect these. The other area is on our developer accounts. We're actually got some scanning now. So this is important, that developer and cloud or your source code or your networks, are very different. They can all expose secrets and contain secrets, but they're having some manual detection on your developer accounts is fundamental, because this is the earliest stage that we can detect a problem. And we all know in security, the earlier the better. But it's not kind of automated. We don't have wide policies across the organization. Perhaps we have some critical developers that are doing some manual scanning on their different systems at time. And when we do have secrets in our source control, they're encrypted. Still not a great idea to do this, even if their encryption can't be cracked. You still have an encrypted file and a single point of failure. But we do see this a lot, secrets being encrypted and stored in repositories so that they can easily be shared. But we have created now a single step of failure. So we're not using our vaults and our secret managers to their full effects. And then we're starting to scan some different areas on critical infrastructure somewhat automatedly. I mean, somewhat automatedly is that there's certain automated triggers that will create a scan. Perhaps we're scanning in our CI/CD environment or GitHub Actions on pull requests or merge requests. So we're getting some coverage, but things can still be missed in histories. Things can still be missed in non-critical infrastructure and other areas. But here we're starting to get some maturity into it. And once we get to level 3, this is basically some significant investment has been made into your secrets management across policies, governance, detection, and storage. So kind of 4 critical areas that we have here. So the key difference between this and level 2 on the developer side is that we have some automatic secret rotation defined in our policies. So that means that these developers are getting access to secrets, and those secrets are being destroyed after use. This is really important, especially when we talked before about those test secrets, quickly testing something, then using it. Well, now we have policies about when those secrets are meant to be rotated. And this really helps active secrets not ending up in different places. The other key things is that we have blockers in place on the developer side. So when we talked about the secrets that we found in internal source control, the 13,000, the number I've said 1,000 times, it feels like now. But one of the most critical things we have to do is we have to stop the bleeding, right? We can't solve a problem if we're going to keep getting the same amount of volume of secrets into our version control systems. So what we need to do is we need to put automatic blockers in place where a source code contains a secret. And we can do this on the developer side, right? We can do this by doing a push hook, so a pre-push hook or a post-push hook or a pre-receive hook, something that's actually going to block a commit that contains a secret. The developer can then fix that. That secret hasn't been exposed. We don't need to go through the whole process of rotating it, but we're stopping that bleeding. Now, we can't rely on that because they can be bypassed, but we're going to stop that volume. So we can actually start solving problems now. And this is critical in level 3, is that now we're not just kind of paddling upstream. We've got a bit of a momentum, and we can actually start working towards some solutions. We're not storing encrypted secrets anywhere in our version control systems, and we're automatically rotating secrets in our source control. And here's the key thing. In our source controlled and in our environments, we've got automated secrets detection across everything that's running all the time. Why is this important? Is that we need visibility, right? We can't solve a problem we don't know exists. We need to be scanning everything. It needs to be happening in real time. And this can be a huge challenge if you're a really large organization, because it can require a lot of sophistication to be able to do this. So this is already pretty advanced. Most companies would be happy at this, but we have another level, the extreme expert level. But this is the level 4 is where we really should be aiming for. So I'm not going to go through everything again. I just want to point out what's different between level 3 and level 4. In our developer side of things, what we're doing is that we're now including them in the remediation process. So the job is too big just for security engineers. So what we need to do is have some automated processes so that when a secret is leaked, the developer gets a survey. They can be part of that remediation process. In some cases, they can remediate the incident themselves and mark that it's been remediated. So they can be kind of involved into that. That's important because it frees up security teams to be able to do what they need to be able to do. And it goes straight to the developer to be able to solve incidents that they can. Now, this is actually quite hard because we need to make sure that secrets are actually kind of rotated and revoked. We need different checks on these. We need to have logs of all this that happened. And of course, there's some tools that can help do that. But this is really the key difference. We're actually creating DevSecOps now, right? It's not just DevOps with kind of a little bit of sec somewhere around that. We're involving all teams in the security process, and they all have a stake and a role to play. And the other area that we have when we're talking about secrets and issuing secrets is we're starting to use dynamic secrets. Dynamic secrets will come with tools like HashiCorp Vault. I think Doppler and Aquilus also use dynamic secrets. But these secrets that are created and then destroyed after use. So even if one gets into the wild, it's no use because as soon as that secret's been used, it's been destroyed. So this is another area where we're really starting to have some maturity in our secrets detection, in our secrets management, and in the side of secrets on our server. Then, well, we're continuously scanning in real time all of our repositories, yes, of course, but we're also scanning other infrastructure, other areas as well, and we're kind of getting great visibility over everywhere. So we have another poll. So this is the honesty test for everyone. So in your organization where you work, what level, based on what we've said, kind of does everyone feel like they're currently at right now? I'm gonna be curious to see who clicks the do this later button. I can't actually see that, but I'll be curious as to the results of where you honestly think that you are in the secrets detection journey. Now, again, there's no kind of right or wrong answers. The fact that you're here means that you're aware that this is a problem, or at least hopefully you've become aware that this is a problem, and we need to move forward on this. I would say that the vast majority of companies around that 400 developer size, are really kind of early stage, level 1, perhaps level 2. But we actually see not many level 3 organizations, because it really needs to be a focus and a security orientated company. And especially in startups, speed is king, really. So where we're at. Wow. Okay. Honesty check worked out really well. Most people are kind of saying level 0 here. Level 0 and level 2. I actually think that that's probably, probably around about right of where I would expect a lot of organizations to be. Either you're just starting out in this journey, or you've put in some places but you haven't made significant investment yet. And then, of course, we have some level 3s and some level 4s, and that's awesome to be able to see too. So great. Thanks for being honest. You all passed the honesty test. All right. So moving on. So what does it look like when you're building an effective detection and remediation program? So there's a couple of different areas that we really need to have. We need to have monitoring across everything, right? We need visibility. So we need to have access to everything that's going on. We need good detection when it comes to being able to identify these secrets, right? We need to have a great library of really what all these secrets look like, because you've got to remember that secrets are usually high entropy strings. That means strings that appear highly random. But like if you look at the URL of this webinar, that random bunch of letters and numbers at the end, that's a high entropy string. Really hard to distinguish between that and a real secret. So you need to have really good detection over that. Alerting is really important. It needs to be going to the right people at the right time. And so we need to, your program needs to have detection, but also alerting that's going through into your seams, that's going to go to the relevant places. Remediation is a step that people often forget because it's really hard to do at scale, especially if you're just a room full of a couple of AppSec engineers and you're trying to deal with all these secrets. You're dealing with all these developers you've never spoken to before. I'm talking to them about an incident that happened 6 months ago. Remediation is difficult. It needs to involve different areas, and then you need analytics. Why analytics? Well, you need to be able to see the trends. You need to be able to identify what teams are underperforming, where your largest risks are, where your critical secrets are, and what teams that they're within, so that you can actually kind of focus your attention. We're not going to go from level 0 to level 4 overnight. It's a journey. So to be able to get there, we need to have some visibility into what's happening. So GitGuardian, we have some different products to be able to help this on the detection side. So we're deeply focused in just kind of detection. The other areas of the maturity model, we fit into different areas of that. But we provide that key visibility aspect, and we can do this both in public areas. So if a developer that's linked to your company leaks something on github.com, we can find that linked into your company and alert you. But also internally within your systems, we can validate keys. We can help you remediate them. We can provide visibility into all your systems. We natively integrate into whatever tools that you're using. So we can really help in that monitoring stage of getting to that high maturity level there. And one of the core things that we really need to do when we're talking about secret detection in our maturity models is have detection at different areas. We talked about this in the different stages, but we have this visual on the screen here that I want to kind of hone in on. So this is the software development lifecycle. In reality, it's probably not such a nice linear line, but this fits on the screen really well. But you can see we have developer, they've committed some changes. It goes into our remote repository, our CI/CD runs some tests, and then it's deployed. This kind of all happens succinctly in a deployment process. So secrets can be exposed at all of these different areas. So we want to be able to detect secrets right at the very beginning, after the developer has committed some changes, but before they enter into our repository. So we can do this with our developer tools at GitGuardian to really block that, stop that bleeding, right? And be able to do it. Obviously, we can scan in the remote repositories and the other infrastructure that you're using to get visibility into that. Once you're running some CI/CD tests, we can scan at that stage as well. And here's what's really important. After those tests run and we deploy, we can kind of scan your final image. Now, if you don't have secrets at all through that, how could you end up with secrets in your final image? Well, you may be pulling them from different environments, and they may not be handled correctly. This is really what would have happened in that CodeCope instance right at the beginning. They could have done all this right and forgot that last step, and now the secret's exposed and the damage is done. So unfortunately, we need it at every different stage of that as a complete foolproof run of that, so that we know when the incidents happen, we're stopping them where we can, and we're preventing them as early as possible. And yeah, this really comes across different tools for different teams, is what I would kind of say here too. Developers need different tools for your security teams. It's just true. It needs to fit into them. No developer likes to be blocked, right, during their workflow. So they need to have tools that fit in with what they're doing, that enable them to move at the speed of DevOps that we're used to, but also alerting and stopping incidents when they actually occur. So it's really about bringing and truly creating DevSecOps. Security teams have the correct tools to be able to get visibility over everything. The DevOps platforms can integrate secrets detection in what they own in that area of the CI/CD pipelines and the deployment process, and the developers can block them on their workstations in the workflow that they have. So it's about truly integrating DevSecOps and not just using another kind of security buzzword that a marketing team created from that too. And this is kind of like the process of actually, when I talked about the developers in part of the remediation, one of the cool things about GitGuardian is that if a secret occurs, we identify the developer, we send them an automated survey, and if they have the correct permissions, they can even remediate that entirely themselves, and then the GitGuardian platform verifies that the secret is no longer valid, it's been removed from the Git history, and there's a complete log of all of that as well. So remediation is a really important part of that process that people often forget, and if we can go straight to the source of the problem, the developers often, then that's fantastic. We can save time through that. So just got some concluding notes before I'm going to pass it over to some Q&A and some detections. But really, there's three pillars that make up a good secrets management. There's the processes. We need to have governance and policies, and we need to have a vision of how this should work. That's really important. That by itself is not enough. Any of these things by itself isn't enough. But that is something that we really need to have a vision and an idea of how all of this works together. We need the people. We need to train our people on this, and we need to get them actively involved in the security process. You'll be amazed that when you actually give people like developers real insight into the security process, and that you're not just knocking on their door when an incident happens, that they really adapt to that and can be part of the team in solving that issue. And of course, you need tools. You need secrets managers, HashiCorp Vault, a keyless, or Doppler, or whatever secret, AWS secrets manager. You need to have the right tools for the right job. Having good secrets management tools doesn't always mean that you go for the best of the breed. HashiCorp Vault is a fantastic tool, but it's very complicated to set up. And maybe if you're a young startup, you want to be using something that's going to adapt to your team a little bit better. But of course, you need secrets detection. You need visibility over where these secrets get let loose, because they're going to get let loose. It's a kind of a weird phenomenon, but it's going to happen. But you need to get visibility over where that happens. So processes, people, and tools together, these are the three pillars that you really need to work on. By themselves, they don't work. It's unfortunately not something you can just throw money at to provide solutions to. These all need to work succinctly together. All right, so I'm going to hand it over now to some questions. I'm going to stop sharing my screen. And I'm going to have a look in the Q&A tab to see if any of you guys have some questions. What's my opinion on, okay, we can publish this one. What's my opinion on, what's my opinion on valid use cases for hard-coded secrets? Business cases for security risks. No, I don't think there's any really valid cases for hard coding a secret. So the argument like for would be that you can get things happening quickly. But even if this doesn't end up in your environment, your runtime environment, that's an extremely risky situation that you've created by having that in the history, by having it in different areas. So, I mean, the business use case, right, would be speed to be able to get something going quickly, or the fact that the team aren't really fully trained on the risk of that. But it's not really a valid use case because these secrets can really hold the keys to the kingdom, and you can't really define of which ones are kind of high risk and which ones not. My favorite example is Slack webhooks, because Slack webhooks are everywhere. Like on GitHub, it's like when developers do a personal project at work, one of the often things that they do is they create like a Slack bot to help with their work processes. This is what I'm kind of assuming, and I've certainly seen it in some cases. These aren't considered critical secrets because all that you can do is post a message on a channel. And I guess you can deem that as not critical. This is literally my favorite attack path to get initial access, because if I can have access to your internal Slack channel, I can post on there, then I can do an internal phishing campaign that appears to come from the company itself, which is fantastic for an adversary because because now I've broken down the first stage of trust. And I'm guaranteed to get someone. Once I'm into your internal systems, maybe I'll get VPN access, maybe I'll get email access or something else. Then you can. So the use case for hard-coding secrets is really not there. Even if it's something that you deem uncritical, even test environments, there's so many different ways that you can use them. And once the attacker is inside, it's really hard to shake him out, especially if you don't know it's there. Oh, here's a good one here. Won't the standard SAST, so static analysis, kind of code testing tools, or SCA tools detect secrets violations? So SCA really focuses on dependencies, so they're not really worried about secrets, but static application security testing, SAST tools, can actually contain some secrets detection. But here's what's really important to notice about those. SAST tools are concerned at the final stage of your application. So I've built my application, and now I'm going to test it, right? And okay, there's some secrets in there. We can remove those and we move forward. It's not concerned about the entire history, right? Which is where the real risk lies. The current version probably doesn't contain secrets. What will contain secrets is the history, the development branches area. SAST isn't enough to kind of go through all of that. Why bother trying to find security vulnerabilities on your entire source code if all that matters is the current version? And that's the view of SAST. Now, the other area is secrets detection is actually really, really difficult. It's because it's probabilistic by nature, because you can, with some secrets, like an AWS credential, we can verify it with AWS. Yes, it's a valid key. It gives access to this stuff. Mark it as valid. That's the best case scenario. 90% of secrets, or about 80% of secrets, are not there. They're private keys that we don't know what they give access to. RSA keys. They might be encryption keys. They may be secrets that you've created yourself. Really, really, really hard to detect these with a high precision and limited recall. So this is why you need a dedicated tool for this to be able to do that. I've actually just realized the time here. I've been carried away in my answers. I was told to give 2 minutes at the end. You have 30 seconds, go. No. But I'll hand it over to you, Cody, right now.
All right, thanks so much, Mackenzie. I really don't mind you going over a little bit. So I would like to remind our audience that today's session was recorded. So following this program, you'll receive an email with a link to access this recording on demand, or you can find it living on the Security Boulevard website at securityboulevard.com/webinars. I did also mention that we have 4 $25 Amazon gift cards to give out. So our 4 winners are Gurish K, Brennan S, John N, and Cindy L. So to our 4 winners, congratulations. Please keep an eye on your email inbox to claim that gift card. But if you don't happen to see that email, do check your spam folder. Now, Mackenzie, I do want to give you an opportunity to wrap up if you do have any final words that you'd like to say before we close out.
Yeah, great. I just wanted to thank you for the opportunity. I hope everyone found it interesting. Sorry, I lost track of time. I always get a bit carried away in my answers, but yeah, no, it was really good. There was a bunch of great questions on there, and if you did ask a question and I didn't respond to you, then hopefully I'll be able to kind of maybe answer that via email or something later on. But thank you all for participating, and yeah, I hope you found the presentation interesting. Yeah, and check out GitGuardian if you think it might be useful.
Awesome. Thank you so much, Mackenzie. I'd also like to thank GitGuardian for sponsoring today's program. And to our audience, thank you so much for being here with us. We do really appreciate you spending the last 60 minutes with us. And we do just want to ask for 1 extra minute, as a post-webinar survey should pop up on your screen as soon as we close out. So if you fill that out for us, we'd really appreciate it. Otherwise, we do hope to see everyone at an upcoming TechStrong Learning program. Everyone have a great rest of your day.